Good morning, everyone. In previous lecture, we have already discussed to a basic of power electronics, its introductions, and we have already covered the topic of power diodes. And in previous lecture, we have covered the topic of power transistor. Now, before start, I am just asking one question by BJT name is bipolar junction transistor. I by BJT name is bipolar junction transistor. Because BJT bipolar junction transistors have electrons and source for the charge carriers and participates for the conductions of the current. And also BJT, also known as BJT's other name is current controlling device. Why? Because BJT's collector currents totally depend on the base current. It means what? All times highly depends collector currents highly depends on the junction temperature, which is main features of BJT. That's why BJT also called current controlling device. Now today we will start the topic of Mosfet. Means in this lecture we will discuss about the topic of Mosfet, its working, its construction, its structure, each and everything. Now let's start. Firstly, power Mosfet. In power electronics, we have discussed all the topics: power diodes, power transistor, power Mosfet. Yeah. Firstly, start the topic. Everyone want to know what is the full name of Mosfet. The full name of Mosfet is that metal oxide semiconductor field effect transistor. What? Metal oxide semiconductor field effect transistor. Yeah. And second important point for the MOSFET is that power MOSFET are having high switching frequency up to about 100 kilohertz. And the feature of power MOSFETs are it's a low input current. It is a voltage controlling device. BJT has current controlling device, but MOSFET has voltage controlling device. Why? We will see in this lecture. High switching speed, active device. It's a basic feature of MOSFET. What? Low input current. It is a voltage controlling device. Why? We will see. High switching speed and active device. Next, symbol of power MOSFET. Now, everyone know diodes terminals, two terminals, anode and cathode. Transistor have two terminals, three terminals, emitter, base and collector. Similar, in the MOSFET have three terminals. First one is a drain, source and gate. Just like that, you can see here symbol of the MOSFET. It's have a three terminal: gate, drain and source. What? Gate, drain and source. The symbol. We are connecting gate here in the middle part, drain is here and source is here. And put up the arrow side. Means if arrow is entering inner side, means what? It's a N channel. If arrow is outside, it means it's a P channel. It's a type of MOSFET, P channel and N channel. We have already discussed in last lecture. MOSFET have two types, N type and P type. Yeah. So, N type, for N type symbols, you will draw this arrow side in the inside, and for the N channel, you will draw the arrow side in the outside. So, please remember that MOSFET have three terminals: drain, source, and gate. Now, The structure of MOSFET. What? Structure of MOSFET. So, structure of MOSFET is there. It's a four net. N plus, P, N minus, as well as N plus. Here, drain is connected with the N plus layer. Source is connected with the N plus layer. And gate is connected with P layer. Here P and here gate is connected. But before connecting gate terminal, its terminal is insulated with the SiO2 layer. Here, before connecting of gate terminal, we are insulated with SiO2 layer. Why? Because SiO2 layer is important for the insulation. It's work as a capacitor. In this working, we will discuss in the working of MOSFET. Okay. And this middle layer is known as drift layer. What is the working of drift layer? Drift layer is important for improve the switching capacity of the MOSFET. First point. Second one is that it's handling voltage capacity of the MOSFET. I told two important points. SiO2 layer for insulation and drift layer. Drift layer for what? For improving switching capacity of MOSFET as well as for voltage handling capacity of MOSFET. So this is the basic structure of power MOSFET. Now we'll discuss about, now I am explain about the working of power MOSFET. So it is a diagram for the working of power MOSFET. You see here N plus, and P. Yeah, connected. Now this is the gate terminal. This one is the body terminal, and this is the source terminal, and this is the drain terminal. In structure, you already see drain connected with N plus, source connected with the N plus, and gate is connected with the P. So same here. Here insulation is there. Okay, SiO2. Okay. So before start working, 2 points is important.